Hello my dear students, welcome back to my channel. My name is Prachi and today we'll be getting back to the second part of hydrogen chloride and we'll be discussing the lab preparation for HCl in this video. So let's get started with that. Alright students, I hope you can see my screen now. So this is the lab preparation setup that we have on the screen right here. So we'll go step by step through every part of it and understand what's happening. So the first part is that you have concentrated sulfuric acid in the Hcl funnel right here. Then in the beaker over here you have NaCl. So through the Hcl funnel you have concentrated sulfuric acid coming down below and reacting with NaCl. Now let's look at the reaction that is happening at the first step. So this is NaCl plus H2SO4, which is giving us NaHSO4 plus HCl. So this is happening at below 200 degrees Celsius. We'll understand why the temperature is important in a minute. So for now, you have NaCl reacting with sulfuric acid below 200 degrees Celsius, giving you HCl gas. So this HCl gas that is prepared after the reaction will slowly travel through the delivery tube into a beaker where you can see concentrated H2SO4 is written again. So concentrated H2SO4. Now why is concentrated H2SO4 present there? So concentrated H2SO4 is a very good drying agent. So when HCl gas is prepared, your hydrogen chloride gas is prepared, it may contain some moisture. So before we come on to the last step of collection, we need to dry out this particular gas. So for that, it will go through concentrated H2SO4, end up drying out, move to the next part of the tube and end up being collected in the collecting jar. This is known as collecting jar. In certain books it is also just written as a test tube. Now what is the method or how do we collect HCl gas? So HCl gas is collected by the upward displacement of air. So what do we mean by that? This means that HCl gas is heavier than air. So if you have a particular jar, a collecting jar like this, and it is filled with air, and slowly you start pouring in HCl gas will start settling from the bottom and eventually all the air will be thrown out. Air is coming out from that. So and then if you look at the collection, then you just have HCl gas in the beaker and the air has moved out. Now the same reaction can happen at above 200 degrees Celsius and you will still get HCl gas as the output. So you have NaCl plus H2SO4 at above 200 degrees Celsius, you will get Na2SO4 plus HCl. But we do not use this reaction. Why is that? The reason is that Na2SO4 that we have just collected here is a very sticky substance. So it is a sticky substance. Whatever apparatus we are using in the lab for the preparation, it will stick to the beaker completely and it would be very hard to clean it after the experiment is done, after the preparation is done. Hence, we do not use this particular reaction in which you have a temperature above 200 degrees Celsius. The second reason is wastage of fuel. So you do have to remember these two particular points very neatly, that if you have Na2SO4, it is a sticky substance, it will destroy the glass apparatus. The second is continuing the reaction at above 200 degrees Celsius, you have to maintain the temperature by using a lot more fuel, although you can get HCl gas by temperature lower than 200 degrees Celsius. Therefore, we do not prefer the second reaction. Now, let's look at the kind of questions you may get from this particular experiment setup. So the first is why NaCl is used over other metallic chlorides. So NaCl is used over other metallic chlorides because it is very cheap and it is easily available. The second question is, why concentrated HNO3 not used to prepare HCl? The reason is that it is a volatile acid. So it may vaporize and you may lose a lot of acid while preparing in the laboratory, while you are doing the preparation for HCl in the laboratory. So we always prefer an acid which is a non-volatile. Hence, H2SO4 is a non-volatile acid. So if they ask you in the question like why are we using these particular reactants for the preparation? So the first is that NaCl is cheap. The second is that H2SO4 is a non-volatile acid. Therefore, we use these two particular reactants for the preparation of HCl gas. Okay, moving on to question number 3. Why HCl gas cannot be dried over quicklime or P2O5? So both of them, we know that quicklime and phosphorus pentoxide are good drying agents, but they do not work for HCl gas. The reason is that they both end up reacting with HCl gas instead of drying it out. So let's look at the reaction that would take place. So quicklime is what? It is CaO, calcium oxide, plus HCl gas, which will give me CaCl2, calcium chloride, plus water. Hence the reaction happened. Then P2O5, that is phosphorus pentoxide. So let's look at that. So P2O5 plus HCl will end up giving me POCl3 plus HPO3. Now moving on, I'm not balancing these equations, so you can balance them in homework and let me know in the comment section if there is any issue with the balancing. Now question 4th, why we maintain the temperature below 200 degrees Celsius? We just discussed it, so I'll just go ahead and write the answers. The first part is that Na2SO4 produced is a sticky substance, and the second reason is fuel wastage. Okay. Now moving on, we have collection of HCl gas. How is HCl gas collected? We discussed it a few minutes ago. So the first is that it is collected by the upward displacement of air. So upward displacement of air. And second point in this is that it is not collected over water. That is because it is soluble in water. So it will dissolve and form HCl acid instead of being collected as HCl gas. So it is never collected over water. Never collected over water as it is highly soluble in water. Okay, now HCl is a colorless gas. So how do we identify that the jar is full? So we have two ways of identifying it. The first is, as soon as the jar is full, a certain type of fumes, like you can identify it, fumes start showing up at the top of the jar. So if you have the jar like this and it is full of HCl gas, so you'll have some fumes showing up at the top of the jar, leaving the jar. So this is fumes that are visible, which can help us identify that HCl gas is collected, like it is full to the brim. The second way is that you can bring, so if this is HCl gas, you can bring a glass rod dipped in NH4OH, that is ammonium hydroxide, near the top of the jar, near the fumes of the jar. And if you see white dense fumes appear. If you see white dense fumes at the top of the jar being formed because of NH4OH being reacted with HCl gas, that means this particular jar is full of HCl gas. Okay, let's look at the reaction that is taking place right here. So you have ammonium hydroxide, that is NH4OH plus HCl, and that will give us NH4Cl plus water. So this is your dense white fumes which confirm the presence of HCl gas. Now, what are the precautions that we need to keep in mind while doing the entire lab preparation of HCl? So the first is that the blower end or the thistle funnel should be dipped in concentrated H2SO4. So the lower end of thistle funnel should be dipped. The second is that the delivery tube that you have that goes to concentrated H2SO4 for drying, so that delivery tube should be dipped in the drying agent. So delivery tube should be dipped in drying agent. And the last is to maintain the temperature. Now we have discussed the temperature part before, so I'll just go ahead and write that maintain temperature below 200 degrees Celsius. And we've done it twice, like why do we need to maintain the temperature at below 200 degrees Celsius. Once we are done with this chapter, I will be sharing all the handwritten notes at the end of it. But with each part, I would try that I'll share whatever I have done during the class. So you have class notes separate and handwritten notes separate. So these class notes would be given to you in the description box below. Okay students, this is it for today's session. I hope this was an interesting session for you. In the next one, we would be covering the physical and chemical properties of HCl gas. If you have any suggestions, if you have any doubts, feel free to leave a comment down below. Looking forward to seeing you in the next session. Please like, share and subscribe this channel. Thank you so much for all your love and support.